Hi, and welcome to another episode in the series in which I am attempting projects from Charles Platt's excellent introductory volume to electronics called Make Electronics. So in the previous episode we looked at switches, maybe not the most exciting topic in electronics, but it's going to get a bit more interesting today because we're looking at another type of switch, which is this. This is a relay. And unlike the manually operated switches we were looking at in the previous episode, this switch can be operated automatically simply by applying a current in our circuit. So let's see how that works.
So here's an example of a switch, a single pole double throw switch. This is a slightly smaller variant than the one that we were looking at in the previous episode, but the same principles apply. And as you'll recall, there's a central pin which is common, which is always connected, and it's connected to either of the outer pins depending on the position of the switch. And although the relay may look vastly more complicated, I mean, you've got an array of pins on the bottom there. In fact, it isn't at all. The same principles apply. So let's ignore these bottom two pins for the moment. I'll come on to those in a second. And the 6 pins at the top are effectively 2 pairs of duplicated pins because you remember we talked about a single pole or double pole switch. And this was an example of a single pole switch that you could only connect to a single circuit or part of a circuit. This is an example of a double pole switch. You can connect it to 2 different circuits or 2 different parts of the same circuit. So in fact, we can ignore one side of these 3 pins as well. And that just leaves us with 3 pins here. And they function in exactly the same way as the pins on our manual switch. The only difference in this case is just the ordering, because in this case, it's the first pin here that's the common one. And then these are the 2 pins that you switch the connection between. So that's actually quite simple. But then, of course, that begs the question, how do you make that switch? Because obviously this isn't a manual switch. There's no kind of controls anywhere. And that's where these bottom 2 pins come in. These bottom 2 pins are connected to a relay coil, a magnetic coil, which can deflect a connector from one side to the other. And so when we apply power to these 2 pins, the connector will be deflected and it will change from connecting the middle pin to this outer pin and instead connect it to the top pin there. So let me hook this up and we can actually see that working. So the setup I've got here is I've got my battery. I've connected one side of it to this, which is in fact another type of switch. We haven't encountered these yet. It's a push button switch. Now the book does actually recommend that you use a momentary switch, which you have to keep pressed down. Because I wanted to use a large switch and these were the only types that I had available, this one is actually a latching switch. So when you push it in, it will stay on until you push it again and then it will come out. But it's sufficient to demonstrate what we want to demonstrate. So what I need to do now is to connect the other side of the switch to one side of the relay coil, and then the other side of the relay coil just connects back to the positive terminal on the battery. Now nothing's going to happen at the moment because I haven't pressed the switch, but if I do, now you can't actually hear anything. Let me see if I can hear it if I'm closer. Yeah, when I put it up to my ear and I press the switch to apply power, I can hear a click as the coil activates and deflects the connector. But it would be nice to have some evidence that that switching is actually happening. So let's use the multimeter for that. I've got it set up on the continuity tester mode. So all I'm going to do is I'm going to connect one side of it to the common always connected pin. and I'm going to connect the other side of it to the top pin. And this is the pin that is normally open, so it's not connected. So we're not getting any sound from the continuity tester, but as soon as I activate the relay coil, there you go, it's now switched over to the other pin. And just to reinforce that, if I apply it to this pin, you'll hear that that pin is no longer connected. We've got no continuity, but if I release the relay coil, there you go, it's connected. So the maybe slightly annoying thing about relays when you're trying to learn electronics is, of course, that they're encapsulated in this opaque plastic box, so you can't really see what's going on inside. You can actually get some relays, usually larger ones, that do have a transparent casing, so you can see what's going on, but not in these small little PCB mounted things. So what we're going to do now is actually sacrifice this one in the cause of science and do what the book suggests, which is to get the casing off it so we can actually see the interior workings and see what's going on. And the way that the book suggests that you do that is to use a craft knife and then to very, very carefully just start shaving down one corner, one edge. And you have to be sort of fairly gentle with it because the casing is not particularly thick, so you don't want to suddenly find yourself going through and damaging the interior components. Okay, so this will, because I've got to do it quite gently, this will take a while. I mean, you've seen the principle of how I'm just shaving down the edge. But what I'll do is I'll carry on doing this until I've got it open and then I'll come back. So I'm not quite done, but I just wanted to show you that you can see how where I've shaved off that corner, it's now started to open up the interior of the relay. And so now I have to just apply it to the other three sides, the same technique, so that we can lift away this top and see what's going on. Okay, now unfortunately this particular type that I've bought here has got a fairly sort of dense inner casing as well, which means that you can't, there's not much that you can see, but what I hope you will be able to see is that these two copper strips along the top are the two switch contacts, and at the moment they're just resting in the lower position, but when I activate the relay coil, hopefully you'll be able to see enough detail on the video to be able to see those lift up. It's a very subtle movement, but can you see that happening? And off and on and off. Let me try and get it closer without losing focus. Yeah, that's probably about as best as I'm going to get. Let me see if you can see it better from the side. If not, you're just going to have to take my word for it that you can see it if you're looking at it in real life close up. And perhaps you can also hear it clicking as it changes from off to on. I'll just be quiet and do it for a few more times to see if you can hear that. Okay, so normally it wouldn't be a very good idea to use an exposed relay like this in a circuit, because obviously there's no longer a casing now to protect it from little bits of dirt and dust and moisture getting into the workings. But hopefully it should survive long enough for us to do some experiments with. So what I'm going to do now is just to hook it up to a simple lighting circuit with an LED, so we can see it turning the LED on and off.
Just to avoid any disappointment, one thing I do want to declare right now, as we're moving into more some of the more complex circuits in the book, is I won't be showing any schematics or any diagrams of breadboard layouts in these videos, because I think it's only fair, if you do want to recreate them, that you do buy a copy of the book. And I thoroughly recommend it. You won't be disappointed. You will have a lot of fun.
Okay, so I've built the circuit from the book, or at least something close to the circuit from the book. I've made a couple of substitutions because I'm using these clear LEDs. But I've got a battery clip on here, which I'll attach the battery to in a moment. Just one tip for battery clips is because obviously these 9-volt battery clips come with these flexible wires, which you will struggle to get into a breadboard, or at least keep in there, even if you do get them in. So what I tend to do is I just solder a very short length of solid core wire to one end, because that's easier to put in and remove from the breadboard. So we've still got our exposed relay on there, and we've got a little button to replace the larger switch that I was using earlier, and we've got 2 LEDs, each connected to one side of the contacts in the relay. So if all is working well, when I attach the battery to this circuit, one of the LEDs should light up. So let's just see if that happens. Yep. So let's just clip the battery in there. So one LED is lit up, and that's the LED that's connected to the normally closed contact on the relay. But if I activate my little push button here, then the relay coil activates. It moves the contacts over so that current is flowing through the other contact, and then the other LED is lit. And likewise, if I remove, it goes back to the other LED, and we can just oscillate between the two of them like so. So what I've done is I've made a small modification to the circuit as suggested in the book. And the gist of it is that one side of the button is now connected through the normally closed contact on the relay. The effect of that is going to be that when I press the button, of course, the coil will energize, but as soon as it does, it will break the connection to the button, which will cause the coil to no longer be energized, and the contacts will switch back again. But of course, as long as I've got my finger on the button, it's going to keep pulsing backwards and forwards rapidly between those two states. So if I just press the button now, can you hear the buzzing? That buzzing is the sound of those contacts rapidly moving backwards and forwards. The other thing you might notice is that you don't really see the second LED becoming lit. And that's because the state is changing so rapidly that effectively any power going to that second LED is very momentary. So I do see a slight flicker in it, but not much. Now, this isn't very healthy for the relay, it has to be said, and if we persist in doing it, it would eventually break. But let's now make one more change to the circuit suggested by the book so that we can see that feedback loop that we've got now working a little bit more slowly. Okay, so I have made a further modification. And I'm sure you noticed that we now have this huge component that's been added to the circuit. This is something called a capacitor, or to be more precise, an electrolytic capacitor. And this is quite a beefy one that is rated at 1,000 microfarads. I'm not going to say anything more about them because they will be the subject of a forthcoming experiment, but the effect that it has is just to slow down that feedback loop that we introduced. So now we will be able to see that second LED momentarily flicking in before the relay contacts close again. Do you see that? It's flicking back. But because of the effect the capacitor is having, we're not getting that rapid quite so rapid oscillation that we were before. So there you go. That is a relay in action.
So if you want to find out why that capacitor had the effect it did on the circuit, please join me for the next experiment when I promise all will be revealed.